Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. So today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement. So this problem is called count good nodes and binary tree, right? So he says given a binary tree root, right? A node X in the tree is named good, right? If in the path from root to X, right, there are no nodes with a value greater than X, right? So it says to return the number of good nodes in the binary tree, right? So pretty much, guys, what they're telling us that, we need to find the number of good nodes, right? Pretty much a node is considered good, right? If, right, X that they mean. So let's say, we got a node, right? Particular node, right? Starting from the root and up to that node, right? That path, right? There should be no nodes that are greater than it, right? Any node that came prior to it, that let's say, from one's perspective, right? From three to the path from 3 to 1, right? There should be no nodes that's greater than 1, right? If we're gonna consider 1 to be a good node, right? And then that 3, right? Just like the path from the root to this node, I say X is 3, right? There should be no nodes that's greater than 3, right? So that's pretty much what they're saying right there, right? So that's the whole premise of this question, guys. I'm saying. So as you guys can see, those are the nodes. So we see 3, this path, right? There are 2 good nodes, right? Because 3, 1 is not a good node because 3 is greater than 1, right? Because that path, that's not a good path. So from this one, right? From this path, from 3 to 3, right? This 3 is a good node because there are no nodes that are greater than 3, guys. There's one that's equal to it, but there are no nodes that are greater than 3, right? So that's a good node. So that's like likewise, we see 4, right? 4 is a good node because that path, right, from 3 to 4, there are no nodes greater than 4, right? I'm saying. So 3 is a good node of jump because there are no nodes that came prior are greater than 3, right? So 5 is a good node because in that path, right, 3, 4, 5, right? 5 is greater than any number that came prior to it, right? So 1 is not a good node because 1 is because that path 3, 4, 1, right? 4 is greater than 1, right? So 1 is not greater than 3, right? So if it was 0, -1, right? 1 would have been considered a good node because in that path, right? There would have been no nodes that are greater than 1, right? So yeah, guys, that's the whole thing. So that's how they're able to get this. So guys, you might say, how can we solve it, guys? We're gonna solve it in a pretty good way, guys. We're gonna be applying recursive. We're gonna be doing recursively, guys. You know what I'm saying? Depth of search to pretty much solve it. So I'm gonna go through a walkthrough with you guys on. So pretty much, guys, we're gonna be passing in the maximum that we've seen so far, right? So we pass it to our children, right? And then our children's gonna check, right? Is their value greater than or equal to that maximum that we've seen so far, right? If it is, we account for that, right? And then we recursively check our children, right? And we pass as the maximum so far, either it's the node that we're currently on or the maximum that we've seen so far. So the maximum of the two, right? We pass it in to our children, and our children's gonna check themselves with that value that you give it. You know what I'm saying. So I'm gonna go through a quick walkthrough with you guys, for you guys can understand it real quick. So you're gonna be a quick walkthrough, and I'll see you guys in a little bit. So yeah, guys, so we're gonna quickly go over that, right? So the example that I'm gonna give right now is the example that I have right now is the example that's included in the LeetCode, right? So right now, guys, when we first start, right, the maximum value, guys, that we've seen in that path, right, we give it, a very small number, a negative infinity, right? So that because we're gonna recursively check, guys, we're gonna compare the node that we're currently on, right? We're gonna compare it with the maximum so far, right, that we've seen along that path, right? You know what I'm saying? So when we first start, right, the root is always going to be included, right? So we account for that, right? Root is a good node, right? Because I told you guys a good node, right, is a node starting from the root to up to that node, right? There are no nodes that are greater than that node's value, right? So 3 is the good node, so we account for it, right? So we go on to the next one, right? So 3 is gonna pass in 3 to 1, right? To each children, right? So 3 is gonna pass in 3 to 1, and it's gonna pass in 3 to 4, because 3 is the maximum value in that path, right? That we've seen so far. So that's why we're passing the maximum, which is 3, right? If 3 is greater than negative infinity, right? So once we're at 1, right, we're gonna ask ourselves, is 1 greater than 3, right? No, 1's not greater than 3, so 1 is not a good node, right? So we don't account for it, so we skip it, right? So 1 is gonna pass in 1 or 3, right? So which one is gonna pass, guys? It's gonna pass in 3, because 3, guys, is the maximum that we've seen, since 1 is not bigger than 3, right? So we pass in 3 to 3, right? So 1 is gonna passes 3 to 3, right? So 3 is gonna check, right? Is 3 greater than or equal to 3, right? Then the maximum that we've seen so far in that path, right? In that path, only considering those numbers, right? 3, 1, 3, right? 3 is a good node, right? Because there are no nodes that are greater than 3, right? So we account for it, guys. So 3 becomes a good node, right? We mark it. Then we get back up, right? And then we check the right side now, right? We check. I told you guys 3 was gonna pass in 3 to 4 as well, right? So that's what it's doing right now. So we pass in 3, right? And then 4 is gonna check, right? 4 is 4 greater than 3? Yeah, 4 is greater than 3, right? So now 4 is gonna be marked as a good node, right? And then now 4 is gonna pass into its children, right? It's gonna pass 4, right? Since 4 is greater than 3, right? So that we're passing 4, so that now the children are gonna check themselves with the maximum value that we've seen so far along that path, right? So we go to 1, right? 1 is not a good node, guys, because there's a maximum there's a node, right, in that path, right, that led up to 1, right? Up to 1, right? There's a node that's greater than 1, right? There are 2 nodes that are greater than 1, so 1 has no chance at all, right? So 1 is not a good node, right? Then we go back up and then we check the right side right now. The right side, guys, we can see that 5 is greater than the maximum value that we've seen so far in that path, right? So 5, we mark it as a good node, because there are no nodes along that path, right? From 3, 4, 5, right? There are no nodes that are greater than 5, right? So that just likewise, if 5 had children, right, we would have passed 5 to our children, because at that level, right, at 5 level, 5 is the biggest number that we've seen so far. So that's the whole algorithm, guys. So hopefully you guys were able to understand the walkthrough I just did, right, and the thought process. So now let's go ahead and jump into the code. All right, yeah, let's get started real quick. So guys, we're gonna be using an instance variable, right? So pretty much property of the class, right? So pretty much that's gonna help us in keeping track of the number of nodes that are good, right? And then guys, so that's how we're gonna, so pretty much we're gonna, as we're checking, right, if a node is a good node, right, we're just gonna increment the count to account for that node, right? That's the coloring that I did, right, and that walkthrough that I just did just now. So that's how we're gonna simulate that, right, by accounting for it and keep checking and do the recursive calls, right? So pretty much, guys, once call the function, right, count is going to go to 0, right? And then, guys, we're going to use this function, guys, that's called DFS, right? DFS. We're going to be passing some parameters, right? After we're done with the recursive call, right, we're going to be passing in the count. We're going to be returning count, right, as the result, right, that we've obtained, right, from our algorithm, right? So pretty much, guys, we're going to pass in the root, right? And then we're going to be passing in, guys, also the integer that min value, right? Pretty much a very, very small number, I'm saying, to account for it, right? Just like I did in the walkthrough, all right? So, and after that, guys, we recurse, so we use this function, DFS, right? Going to be doing depth first search. And then, so we're going to be passing in the root, right, as a parameter. And then we're also going to pass in the maximum that we've seen so far, right? Maximum so far, let's call it that. And now we check, guys, if the root equals null, right? We're simply gonna return, right? That's our base case, guys. So I'm saying. And then, guys, we do the check, right? The important check, right? The root, that val, right? Is it greater than or equal to the maximum that we've seen so far, right? Right. After that, guys, if it is, guys, we account for one, right? We account for it, right? Right, and then, guys, we're recursively going to check. We'll recursively check our left child. So what do we pass in, right? I told you guys, we either pass in the root that we're currently on, right? The value of the root that we're currently on, right? Or the maximum that we've seen so far, right? So we pass in either one, right? And then we do the same thing for the right child. We pass in map.max, right? Either root that val or the maximum that we've seen so far. You know what I'm saying? So yeah, that's kind of the whole thing, right? So let's check if we pass these small test cases, guys. Perfect. This looks good. Let's see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys in the next one.